Welcome to this review of derivatives and function behavior. Let's test our understanding with a few true or false questions. For all these questions, assume functions are differentiable everywhere. Pause the video if you want to think for a second. First, if f is decreasing on the closed interval from 0 to 2, must f of 0 greater than f of 1 greater than f of 2? This statement is true. By the mathematical definition, a function is decreasing on an interval if, for any two values where x1 is less than x2, the corresponding function value f of x1 is greater than f of x2. Since 0 is less than 1 and 1 is less than 2, it directly follows that f of 0 must be greater than f of 1, which is greater than f of 2. Next, if the derivative of f at x equals 1 is positive, is f guaranteed to be increasing on the entire interval from 0 to 2? This statement is false. For a counterexample, consider the function f of x equal 2x minus 1 square. Its derivative is f prime of x equals 4 times 2x minus 1, which is equal to 4 at x equals 1. However, evaluating the function at local points shows that f of 0 is equal to 1 and f of 1/2 equals 0. Because the function value decreases from 1 to 0 on this interval, the function is not increasing on the interval from 0 to 2. Conversely, if f is increasing on the interval from 0 to 2, must its derivative at x equals 1 be strictly greater than 0? This statement is also false. Consider the counterexample f of x equals x minus 1 cube. This function is strictly increasing on the interval from 0 to 2. However, its derivative at x equals 1 is 0. Thus, a function can be strictly increasing even if its derivative is 0 at an isolated point. Finally, if the derivative f prime is increasing on the interval from 0 to 1 and decreasing on the interval from 1 to 2, does f have an inflection point at x equals 1? This statement is true. On the interval from 0 to 1, because the first derivative is increasing, the function is concave up. On the interval from 1 to 2, because the first derivative is decreasing, the function is concave down. Since the function is continuous and changes its concavity at x equals 1, it meets the definition of having an inflection point at x equals 1.